All right, in today's video reference, we're going to look at the last section of this chapter, which is 4.7, graphing linear functions. But really, we're really just looking at function notation. And if you don't remember anything or learn anything from this video, the one thing you need to know is that function notation, which is written like this. In this symbol, f of x is another name for y, really. So that's all f of x is. It's just when you see f of x, really just think of that as your y variable or your input. So the way you say that is f of x. It does not mean f times x. You can use letters other than f, such as g or h of x, when you're naming functions. So basically, let's look at some examples. So what is the value of the function f of x equals 3x minus 15 when x is negative 3? So really, you're not doing anything. If you want to even replace it here, you could write y equals 3x minus 15. And what they really want you to do here is just plug in x. So can someone tell me what would you do to get the answer here? Yeah, 3 times negative 3 minus 15. So we'll put it back to function notation. And so the final answer, raise your hand. Does anyone know what negative 3 times 3 is minus 15? Yeah, it's negative 24. So that's really all we're doing here. The other thing that they'll sometimes do is they'll give you the f of x equals 6. So in this case, really what they're just giving you here is they're just telling you that y equals 6, or they want you to replace your f of x here, and here they want you to put the number 6. So now you're going to have to do some solving. So if I do this, it would be 6 equals 2x minus 10. Raise your hand. What's the first thing I do here? Plus 10 here, plus 10 here. 16 equals 2x, divide by 2, divide by 2, and x equals 8. The other thing that comes up in this section that's really important is we're introduced to what's called the parent linear function. It's the most basic linear function there is, and that's f of x equals x. Or in other words, raise your hand if we replace f of x, what would that kind of look like too? Yeah, it'd just be y equals x. So this is it. So if you kind of look more at this actual equation, so y equals x, raise your hand. What's the slope? Hopefully you said and assumed 1. And then what's the y-intercept? Hopefully you said 0. So if you look at the most basic linear function here, the parent function, it really just starts at 0, 0, goes up 1 over 1. And so, like, let's say we wanted to compare it. It's right. F of x equals x plus 1. So can someone tell me, if I was to graph that, what would be the difference between f of x equals x and x plus 1? Yeah, hopefully you said it would just go up 1 and have the same slope and be parallel. So you would just write, same slope, shifted up 1. And if you want to see a graph, I'll do it here for you. You could just go here, 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 here. So like that. Let's just do one more comparison. What if we had f of x equals 1/2 x? Let's see. Yeah, just 1/2 x. So why don't you talk to your neighbor and compare that to the parent function f of x equals x or y equals x. So hopefully, did you say something that the y-intercept is the same? So same y-intercept. And then maybe you said a smaller slope or a less slope or less steep of a line, however you word it. So again, this one, if you did this one here in blue, you'd stay here, but now your line would be up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2. And so that'd be like that. Let's do one more. Let's do one more, and then we'll look at the notes here. So let's say we compared f of x equals, let's do 3x minus 2. So that's very different than our parent function. When you compare it, what are the differences, I guess you could say? So maybe you said shifted down 2 units. Sorry. And then maybe you also said steeper or greater slope. So if I did this let's see, I kind of ran out of colors. I'll do it in black though. So this one would be here, a -2. It'd be up 3 over 1, up 3 over 1, down 3, left 1. So, sorry, down 3, left 1. So it would look kind of like that. And again, what we did today is just compare that all to the parent function, which is here in yellow. So again, that's kind of what we're going to be looking at in this last section.